This video demonstrates hybrid service chaining with compute nodes that run different types of hypervisors. More specifically, we focus on KVM and ESXi. While OpenStack talks directly to KVM hosts, this ESXi integration follows a model called vCenter as compute. If you want to spawn a new VM on an ESXi server, OpenStack performs the compute orchestration and talks to vCenter, which in turn talks to the ESXi server. However, overlay network orchestration, such as the advertisement of tenant routes and policies, takes place between the Contrail controller and the vRouter agents. vCenter is not involved in that part of the signaling. The ESXi hosts run different types of virtual machines or VMs. First, a Contrail VM, which contains a vRouter and its corresponding vRouter agent. Additionally, there are tenant VMs in the green and red virtual networks. These VMs have just one network interface, but they could also have a left and a right interface and act as service instances. After this brief description of the model, let's look at a hybrid service chain in action. The scenario has 4 physical servers acting as compute nodes. The first server runs Ubuntu with KVM and contains virtual machine A. The second server runs ESXi and contains virtual machine B. The third server runs Ubuntu with KVM and contains virtual machine C. Finally, the fourth server runs ESXi and contains virtual machine D. VMs A and D are simple VMs with just one network interface each. On the other hand, VMs B and C are layer 3 service instances with a left and a right interface each. The flow we are going to illustrate is a simple ping that goes from 10.1.1.5 on VMA to 10.2.2.5 on VMD. And we will demonstrate that the flow goes through the 2 service instances in the chain. Here is the view in Horizon GUI of the 4 VMs A, B, C, and D. As you can see, they belong to different availability zones. Let's have a look at the 6 terminals. The first terminal is on VM A and we use it to send a ping towards VM D. We use the green phone terminals to run TCP dump on the left and the right interfaces of VM B. Then we use the ping phone terminals to run TCP dump on the left and the right interface of VM C. Finally, we use the terminal on the top right to run TCP dump on the only interface of VMD. By playing with the time to leave value, we can determine how far the ICMP echo requests go in the chain. With TTL4, we can reach and traverse the first service instance. Let's copy the ICMP ID of the flow, 5829. Now we look up this flow in Contrail Analytics GUI. The forward flow, composed of ICMP echo request packets, goes through 2 vRouters. One on a KVM server and one on an ESXi. The reverse flow is programmed but has no packets yet, as expected. Now let's increment the TTL so we traverse the second service instance, in pink. Again, let's copy the ICMP ID of this new flow and look it up on Contrail Analytics. The forward flow goes through 3 vRouters, and the reverse flows still have 0 packets. Finally, with TTL7, we can traverse the 4 vRouters and the whole service chain. Here is a new vRouter that corresponds to the vRouter VM running on the second ESXi server. As expected, now the reverse flow has non-zero packets, and this ends the demonstration.